Hi, so let's continue. I don't know why my video suddenly stopped. Where are we? So I think we stopped somewhere here. Let me repeat this thing. Okay, so from the given problem there, so this is the equation that we have, because vector f is conservative, so we have this. Then we need to find what is the potential function f, small f here. So that's what we want to find. So from there, from this equation, so we just equate each of these components. So we have this, that equation number 1, number 2, and number 3 for each of those components. Now, in order to find f, if you look at the equation number 1, you can integrate respect to x. Okay, integrate respect to x. So this is what we have. Integrate respect to x from 1. Alright, so integrate respect to x. So we have f on the left side, and right side give you that, and plus a function of yz. Yeah, because yz is free of x. If you differentiate this give you 0. Then we get back equation number 1. Now, having done that, you look at the purpose now is to find phi 1. Yeah, find phi 1. How to find phi 1? Now, look at the equation number 2. We have done number 1. Use equation number 2. What number 2? We have del f del y. So, therefore, you can differentiate that function with respect to y. Okay, differentiate that function with respect to y. So, you have all this thing. 2xy z cube plus del phi 1 del y, okay, equal to del x y z square. So this from equation number 2. Yeah, look at equation number 2. We have del f del y 2xy cube. So here equal to del 2xy cube. This is from equation 2. And from there, we can solve that. We have del phi 1 del y is equal to 0. Then you can find phi 1 is integrate respect to y that give function of z. Okay, no more x here. X will not appear here because this is a function of yz. Why only yz? Why no x? Because this is come from our first equation here. Okay, we cannot have x. No, only yz. Now, with this process, we know that phi 1 is only function of z. Only function of z. Now, to find phi 2, right, if you substitute into f, our potential function f that we find earlier here, from the first step, okay, so this is xy squared z cubed plus phi 1 is equal to phi 2. So, this is phi 2. Now, we need to find phi 2. In order to find phi 2, look at those equation number 3. We differentiate that with respect to z. So, I can differentiate this with respect to z. Differentiate the equation that with respect to z. So, we have 3xy squared z squared plus d phi 2 dx. This is equal to 3xy squared z squared. This is from equation number 3. That equation number 3 here. So we have those equation. Now from here, these are equal, so there's 0. So we have d phi 2 dz is equal to 0. So therefore we have phi 2 is equal to just a constant c. Okay, so therefore forget about this. So therefore we have our f x y z is equal to x y squared z cube plus phi 1 equal to phi 2 equals to c. So this is plus c. So this is our potential function that we are looking for. Alright, to find further c, if you want to find further C, to find C, in this case, we need the initial condition. Yeah. What is initial condition? Example. At x, y, z equal to, this is just example, okay? Just example. So, for example, if x, y, z equal to what? Let's say 1, 1, 1. Then our f is, let's say, what? 2, for example. Okay, I just pick up, right? Just to give you an idea how to find C. So using this initial condition, you can substitute into the obtained f here. Then we have f is equal to 2. Then f11, so you have 1 squared, 1 cube plus c. Okay, from here you have c equal to 1. Alright, so therefore our f is x, y squared, z cubed plus 1. Okay.